Hello, this is K1, and this is Kerbal Space Program, and this is KerbalOdyssey, my continuing video series in which I tackle the history of the space program. In this case, I will be tackling the what if of history. What if we did not give up on Skylab? For those who do not know, Skylab is an American space station that was built from leftover Apollo parts after the final mission to the moon. NASA was low on its budget, and they needed to put something into space with the money that they could afford. And Skylab was an excellent use of that available funds. Skylab, of course, was sent into space unmanned, so I'll make sure to get rid of everyone occupying seats here. Let's get this thing in the air. As we load our launch pad, the first thing that can be noticed is the Skylab itself. Its launch vehicle is the Saturn V, the same launch vehicles that sent Americans to the moon. Minus one stage. But let's go ahead and get this ball going. And those engines are loud. They push hard. Let's zoom out so we can hear ourselves think here. The launch stack for the Skylab consists of the first two stages of the standard Saturn V. The third stage, however, is essentially hollowed out to form the bulk of the station itself. As we don't need quite as much thrust as Apollo did to get to the moon, because all we're doing is putting the station into orbit as my engines overheat. An interesting note of history is during launch of the Skylab originally, a few things went wrong. Namely, as it was going up into orbit and staged a few times, the shield on the outer side, this meteorite shield and sun shield, had torn off its structure, basically revealing its internal skin to the exposure of space. And this is the side of the station that was meant to face toward the sun. So it's exposed skin facing in direct sunlight. Needless to say, this was very bad for the station. Traditionally, when I launch, I like to get to about 10,000 meters before pitching over. 10,000 meters and at least 200 meters per second. Other people in Kerbal have different or more efficient methods of getting into orbit. This is mine. It is just preference. It's not based on any kind of facts. Here we are about to stage. Dump the lower stage and fire stage 2. This should have enough thrust to get us the rest of the way. In addition to the meteorite shield, one of the solar wings had also torn off the station, and the other was pinned down by a piece of debris, basically a strap that was holding it down. So not only was the station exposed to direct sunlight as it reached orbit, but was getting almost no electrical power. Maybe zoom out and look at our apogee here. Still got a ways to go yet. And this was bad news for the station. Not only was it barely alive with this trickle of power from its stuck solar wing, but it was baking in the sun. And here you have a pressurized compartment with temperatures soaring above 130, even as high as 160 degrees. It was a tremendous danger that the hull would indeed rupture, which would render the station useless and bring an end to manned spaceflight as we knew it. Keeping with my angle of trajectory here, you want to keep your heading pretty close to that trajectory angle. You don't want to be fighting gravity on your way up, because that is not really fun. want to get this thing to approximately 150 kilometers. That's a pretty good altitude, get some distance. 50% fuel remaining. So how did they tackle this problem? Needless to say, they didn't launch the station manned, because they're not going to send astronauts up without any method of ensuring they can return, because the station's never meant to re-enter the atmosphere. What they had to do was tell the station to face away from the sun. Simple. But the problem is, it gained its trajectory. We're at 150, going to lower the thrust here. All of its navigation came from the sun itself. So when the station tilted away from the sun, the computers and the guidance officers couldn't tell where the craft was pointed. And furthermore, when this pointed the solar panels away from the sun, then they no longer got their readings. I'm going to go ahead and switch these around and disengage that shroud, so we can see the first parts of the station. So with only a trickle of power coming in from that one stuck solar wing, they obviously couldn't face it away from the sun, because then the station would be out of power and become just a derelict object and again be lost. So what they had to do was something actually quite interesting and turn over control of the spacecraft not to a guidance or navigation officer, but to an electrical technician known as ECOM, Electrical, Environmental, and Communications. In Mission Control, he occupies a station in the second row called Systems, whereas all the navigation and guidance was in the first row, the trench. Two completely different cultures, basically, and usually different kinds of thinkers. So the two rows weren't really used to having to depend on each other beyond controlling what they were meant to control. So as John Aaron, sitting at ECOM, is trying to delicately guide the Skylab into its proper orientation, using only what his instruments are telling him based on the power incoming from those solar panels and the temperature reading inside the craft, you have the guidance officer looking over the panel. ECOM, tell me something. Do you know what the hell you're doing? And he just looks back up. Just input the commands, we'll be fine. And indeed they were. Took about a week of trial and error, but they finally got the station pointed the way it needed to go, and I'm going to kick some thrust back on here so we can get ourselves into orbit. And things operated pretty smoothly, considering. The Skylab station was saved, but there wasn't much else they could do on the ground. Everything else, including deploying a shield to block the sun, as well as freeing up the stuck solar wing, depended on actual astronauts getting up into orbit and getting it done. I get this to 150 even. Get a little OCD with this. Click, 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 click. 150. 003. Speed up time a little bit to reach that apogee, and then circularize our orbit. And as we're up here, I'm going to go ahead and extend the spacecraft's panels. While they're extending, I'm going to lock onto this course and get myself up in the proper orbit. I want to hit 150 by 150, but we're not going to be too exact, unfortunately. Up, and there we go. 149 by 151. That is pretty good. And let's tilt this puppy toward the sun and get a good look at the familiar structure of Skylab. And here we are. The familiar X shape. That is the solar observatory, and I'm going to get this thing. Now I need to do some trial and error. Upward thrust. Wrong way, downward. Orientation is kind of difficult to gather when you don't have reference points. As we get this thing facing the right way. Oops, I don't want to turn it. Don't want to tilt you. Stay straight. This thing fights me all the way. There we go. And again, OCD. But I want it to look perfect. So here we are. This is our Skylab. This familiar X shape is the solar observatory. And that is what they use to study the sun. And we take that for granted because we know a lot of the sun now, but back then, they didn't know much of anything. And here we have the two solar wings, both fully deployed. This is an undamaged version of Skylab that I am using, again, as a what-if. This engine stage did not stick with the craft when it was actually flying, but I can't really do much with that right now. I don't want to have debris flying around, so I'll have to test that later. And let's return to the Space Center here. And get Apollo! And this will be essentially Skylab 2. The first crew sent to the space station using one of the leftover Apollo command and service modules. Now this is not a Saturn V, obviously. This is the Saturn 1B. Naturally, just to get the command service module in orbit, they didn't need the full launch stack that would go all the way to the moon. This particular launch vehicle, the S-1B, before the launches of Skylab, was only used for Apollo 7 and 9. Let's look up into our orbit. We want the Skylab to be in proper position to rendezvous. We don't want to have to fight orbit for too long. And here she comes. Let's get it just before the tip of what looks like it's trying to be Africa. But there's just a coincidence. So about there, that's a good little course. Let's get that throttle up and these engines firing. Takes a bit to get this thing up to speed. Now I mentioned Apollo 7 and Apollo 9. Apollo 7 was merely the test flight of the command service module. Oh, I'm overheating already. Oh goodness, that is not good. To basically test the spacecraft and make sure it is spaceworthy before they take it anywhere. Apollo 9 took the lunar module into Earth orbit to test it out. Originally the plan was to have Apollo 8 test the lunar module in Earth orbit and then take it into a higher orbit for abort procedures on Apollo 9, and then take it all the way to the moon for a dress rehearsal of the approach procedures on Apollo 10. Well, that didn't exactly happen. Before the flight of Apollo 7 even took off, CIA satellite photos came back with pictures of a huge Russian rocket that was larger than anything that had attempted to launch before. And the worry was that they were aiming for the moon. The competition between nations at this point was fierce. Now, would it really have mattered? That's another what-if in history. But suffice to say, Americans were scared at the time. And they really needed to get their sights on the moon quickly. And it wasn't just that. I mean, that was a contributing factor, but the major contributing factor to the switch was that Grumman, who were designing the lunar module, they were not done building it. There were all loads of problems with it. The systems were not working out. There was just problem after problem. So after the successful flight of Apollo 7 in mid-1968, the worry was they would not have Apollo 8 until about the summer of 1969. And the goal was still to reach the moon by the end of 1969, which was Kennedy's goal of reaching the moon before the end of the decade. And if Kennedy's goal was lost, public sentiment was likely to evaporate, and along with it, funding. So, they had to get some steps ahead and not sacrifice valuable time waiting for the lunar module. So they basically switched the missions of Apollo 8 and 9, saving the lunar module test for later and taking Apollo 8 with just the command and service module all the way to the moon. That's where we first got the historic Earthrise photo of the Earth rising over the lunar surface. So that began our pitch over here. Pitch not quite over as much because this rocket doesn't have quite the power we need. Appropriate theme explorers as the three intrepid explorers Jeb, Bob, and Bill leave the surface of Kerbal. And staging and fire. The Saturn 4B. Look where we're at here. Oh, the station has passed us by. This launch vehicle does not have nearly enough power. So let's start tilting over now. And what is our apoapsis like? Getting... Ah! Well, that matched up pretty good. And we're over here. But after the successful flights of Apollo, because obviously Apollo 8 made it, as well as 9, 10, 11. The only major disaster occurring was 13, and the crew were still recovered alive. Interestingly enough, the commander of Apollo 13 was the command module pilot on Apollo 8, the first flight to go around the moon. Now in this particular instance, as we are portraying Skylab 2, and Skylab just took way off. We're not catching it. So I'm going to set a course to get our orbit below it so we can catch up. So the mission of Skylab 2 was not only to occupy the station, but fix the problems it encountered, namely the missing meteorite shield and the stuck solar wing. The problem with the meteorite shield was actually fairly simple enough. Well, the first thing they had to try and do is maneuver the command module in close and have one of the crew members reach out with a hook device and yank on the solar wing and try and free it. I'm gonna kill her right here. This didn't work, and all it did was jerk the station around. So they had to try something different, which was a few days later. After boarding the station, the first goal was to get that temperature down, because it was still hovering about 130 degrees, which is unbearable to work in. I used to live in Arizona. I know 130 degrees. Ugh, not fun at all. But simple matter of deploying a parasol-like device, basically like a, not tent, but a kind of tint cover that you'd see in a park. And this was deployed through a small hatch on the outside and deployed to cover up the exposed skin of the station. If you were to see a picture of Skylab, you'd see this orange kind of structure. And it did its job. It blocked out the sun and got the temperatures inside the station down to about a comfortable 80 degrees. And it looks like this stage is empty, so let's separate our launch tower. Ditch these panels. And fire our engine. And now we have just the familiar command service module. Let's deploy that antenna too while we're at it. Let's get up to full thrust here. We've still got some pushing to go. So with the temperatures down to manageable levels, the crew stayed aboard the station for about 10 days, a couple weeks, before finally going out. Oh, that debris is on a weird orbit. Oh, that's the escape tower. That's what I get for paying attention. After about their 2 weeks of work, they went out to try and free up the solar wing. And I mentioned the hook device before. The scientifically amazing contraption that they used to free the stuck solar wing was none other than a telephone company tree trimmer. Just a 10-foot long pole with a couple of cords that you pull to pull on the jaws to pull them shut. That would basically trim a tree limb. Well, in this case, they were hoping these jaws would snap the strap, the metal strap that was holding down the stuck solar wing. Well, the problem is, as I round this out, the problem is against the zero gravity vacuum of space, you have no real resistance. And without proper handholds, because no one was ever meant to climb outside Skylab. And the stuck solar wing was in an area that no astronauts were ever meant to go. So there's nothing really to hold on to. So as you try and maneuver this pole around, when you pull on the pole to try and turn it, you actually turn yourself. Because it exerts a greater force on your body than your body exerts on it. And I'm getting close here. I'm going to turn the craft around and try and match up these courses here. So it wasn't until they were able to find an exposed bolt on the outer skin of the spacecraft and hook up their lifeline through it to basically tug his body toward the surface of the station with the cord hooked around this little notch. So by pulling on that, he was now able to press his feet against the station and assume a three-point stance, to which he can get better leverage and snap on that little piece of debris. Oh, here we go. Separation, 50 kilometers. So let's get ourselves in course for rendezvous here. Rendezvous is actually one of the trickier maneuvers in Kerbal Space Program, unless you've done it enough times. So after cutting the strap nice and slick, the solar wing should have extended. Well, it didn't. It just stayed in its position. So he gets the pole underneath it and tries and pulls it free, and it still does nothing. Yanks on it a few more times, yanks on it a few more times. Finally, that wing just snapped right out. And the two astronauts went ass over tea kettle in outer space. Just flip-flopping around. until their lifelines finally extended to their full length and pulled them taut. Now, no one has ever tried to do that before. Naturally, the first worry was, would these lifelines break? Fortunately, they did not. Now, let's use our thrusters here. Let's do some sideways thrust. Bring that separation down. I want to get within a couple kilometers if I can. By the time the lifelines went taut and they'd stop moving away, the first thing they would notice is the solar panels deploying. And now Skylab was able to get its full drink from the sun and operated perfectly ever since. Home for 3 crews before finally being abandoned, with the very last flight of Apollo tasked to what was called the Apollo-Soyuz test project, which is essentially Apollo 18 docking in space with Soyuz 19. Now, this was a goodwill exercise, a cooperation and symbolic end of the space race, but from a scientific standpoint, just another rendezvous and docking, something both nations had done many times before. But with no more Apollo command modules left to fly, there was nothing else to fly up to Skylab. And come 1975, the station would be abandoned until finally re-entering the atmosphere in 1979. Now, the plan after that was to send the space shuttle up to dock with it. Ah, and there's our station, 63 kilometers away. And the space shuttle was even originally tasked to fly in 1979, but did not. There were some tests still to do, and I believe it was more of a symbolic nature that they delayed, because they wanted the first launch in 1981 to fall on the anniversary, I believe, the 25th. No, 61, 71, 81. 20th. The 20th anniversary of the first man in space, and that being Yuri Gagarin. How close are we here? 50 kilometers. We've got some time. I'm going to speed this up here. But of course, the great what-ifs of history. What if we did not choose to abandon Skylab, and instead decided to continue with it, either building upon it or continuing proposed missions thereof? One such proposed mission, it was actually one of the first drafts of the Apollo-Soyuz test project, was having a Russian Soyuz spacecraft actually dock with Skylab and occupy it for a time. Or have an Apollo dock with a Soviet Salyut space station. Now, the problem with this wasn't really a problem, but oh, that's killed at velocity. I'm going to overshoot because I was talking too much. But the problem with that is if the Russians went ahead with that plan, they would have to disclose something that was a little bit classified. Because at the time, they had, I believe, 4 Salyut space stations, 2 of which were actually not Salyut at all. They were military-designed Almaz stations, and they were even armed. So they were reconnaissance stations that were meant for military purposes. They did not want the United States to know about that. And of course, they wouldn't know. We wouldn't know about that until several years later, when it no longer even mattered. But of course, it was a more symbolic nature to have the Apollo and Soyuz dock anyway, so no harm, no foul. And we are on a decent course here. We can actually already see the structure. We'll give a little burn toward our target here. And adjust our course. Skylab is at 1.3 kilometers. I'm going to kick up a little more velocity here. Let's get into about 10 meters per second. And let's get our... Yeah, I'm upside down, so let's tilt that. I like to get it to where when I say thrust up, my craft actually moves up. Makes it far easier to maneuver. And I'm going to move a little bit to the right so I'm not coming dead onto the station here. Unfortunately, the thrust of the Apollo in this particular instance is not particularly uniform. So as I try and maneuver, the craft tilts. Ooh, look at that. Of course, the question is, how visible would it be without the big tank on the backside? That will disappear eventually. That will be my next flight. But in this case, obviously I don't have to repair the station because the station is in full working order. So this crew of Bill, Jebediah, and Bob will just have some fun in the station, doing their science and floating about in zero gravity. Let's go ahead and start lowering my speed. Let's get ourselves back on course here. Oops. Oh boy. Oh boy. Stop, 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 stop. Ah, I missed. Just to make sure we don't bump it. Oh boy. Alrighty. I'm gonna have to get my main engines here. That was spectacular. Get back up there. Arr. Okay. Woo! That could have went better. But it's not like we went too far. Not like my first times. First times I attempted a rendezvous with Kerbal Space Program, I'd overshot by about 5 kilometers. And the next thing I knew, I was 200 kilometers away on the next orbit. You just have to remember that until you get close enough, your goal isn't so much to head toward your target, but rather to match its orbit. And here we go. Let's shine some light on the situation. I'm still moving away, so thrust toward the target. I am underneath it, but still... Here, stay straight. Okay, there we go. Heading toward its primary docking port here. It would help if I was tilted up correctly. Let's Let's lock onto that port. And looks like I am about centered here. And as we make our final approach, I'm going to get myself slowed down and lock back in there. Not so fast. It would help if I actually had a front window view, but it looks like I don't have that here. But that's okay. Instruments do fine. And you come in so slick, and kerclunk! Houston, we have hard dock. And there be our Apollo spacecraft docked with Skylab. And I have 3 Kerbals, and they are all happy. Usually Bill and Bob are freaked out, but they are happy to be aboard Skylab. And why not? It is a big open facility with lots of fun things to do. And this is where they will live for a period of 1 month. Or however long I feel is necessary. But next we will continue. We're not just going to send up more crews, we are going to build on this thing. I've got a couple docking ports here and a couple expansions I plan on adding. So next time we will continue the what if when we bring in the Soyuz and the Salyut and bring them all together. This is building the Skylab in Kerbal Space Program for KerbalOdyssey. This is K1, and thank you so much, and see you all next time.